Hello, my name is Kylie Antonik, and today I'm going to be doing an alcohol elimination dehydration mechanism video supplement to help other students in organic chemistry try to understand the E1 and E2 mechanisms. So first we should go over which alcohols are which, just to recollect which ones are bonded to which, and let's start with primary. So a primary alcohol is when the alcohol is bonded to a carbon, a central carbon, and that only has one other carbon bond. The rest are hydrogen. Secondary alcohols are when the carbon to the alcohol bond have two other carbon bonds. And finally, tertiary is when all three of the four possible bonds are carbon, and then the other one is the oxygen. Primary alcohols undergo E2 reactions, while secondary and tertiary alcohols undergo E1 reactions to form alkenes. And you might be saying, well, why can't primary alcohols undergo an E2 reaction? And the answer is because of the difficulty to form the primary carbocation intermediate. And instead of having that intermediate, a good leaving group is formed and then leaves in replacement of the carbocation intermediate. Okay, so let's start with an E1 mechanism. That means we're going to start with a secondary or tertiary alcohol in the reaction, and we're going to add an acid. Once we add the acid, what's going to happen is this oxygen is going to give an electrons to this, and it's going to form this intermediate. And if you know, this obviously is a positively charged water molecule. So this becomes the intermediate. And what's going to happen is we're going to take the electrons in between this bond, and we're going to give that to the water molecule, and the water molecule is going to leave. Now we're left with a carbocation intermediate. Now that we're left with the carbocation intermediate, what's going to happen is we will have a water molecule that will come up, and it'll take this adjacent hydrogen, and it's going to leave the electrons behind. The electrons are going to form a double bond, and that is going to form our alkene. Once we form our alkene, you notice that there are two products at the end. The two products are isomers. We get them because of the different ways that the molecule can form. So this first one is known as a trans, where the hydrogens are on opposite sides. And then this one is known as a cisalkene, where the hydrogens are on the same side. So here is the same picture from the previous slide. I just went ahead, blew it up so that you could actually see it. And then here are the steps. I numbered them out for you so you can go through and look. And so here we're starting out with our secondary alcohol. The secondary alcohol, we're going to add some type of acid. So here's our H+. The acid is going to protonate right here. So this oxygen is going to give the hydrogen whatever acid. It's going to donate the electrons, and it's going to form a bond then. And then here we have the intermediate. So this forms a good leaving group because now these electrons are able to go between this bond and go onto the oxygen, and now that's a good leaving group, and it'll leave. So the water molecule leaves. And now what we have is the carbocation intermediate. And then once we have the carbocation intermediate, like this says, a water molecule is going to come up, it's going to take this hydrogen, and then we're going to get our alkene. So you can just take a look at that. Okay, so now let's take a look at an E2 mechanism, which we know happens on primary alcohols when that is reacting with an acid. So we're going to react in a primary alcohol with an acid, and what's going to happen is it's going to form a really good leaving group, but we're not going to have a carbocation intermediate. So in order for the alkene to form, what's going to happen is we're going to have this really good leaving group on the molecule, and a base is going to come in. It can be water, or it could be any base like that you have available. But what's going to happen is the base is going to grab a hydrogen off of the molecule, breaking the carbon-hydrogen bond. And then those electrons are going to be transferred until it reaches the leaving group. When it reaches the leaving group is going to leave. And then those electrons are going to be formed in between two of the carbons, and that's going to form our alkene. So just like the last E1 mechanism, I wanted to give you a picture and an example for the E2 mechanism. So here we start out with a primary alcohol on an alkane. What's going to happen is we're going to use an acid. The oxygen is going to form a bond between that hydrogen, okay? And what's going to happen is it's going to form this positively charged water molecule, which is a good leaving group. So now a base can come in. The base can take a hydrogen off, and when it takes the hydrogen off, the electrons are going to be pushed until it gets to the leaving group, and a water molecule is going to leave. Once a water molecule leaves, what's going to happen is since this is no longer there, we have to fill the gap. So an alkene is going to form, and this is how the E2 mechanism happens for primary alcohols. There's no carbocation intermediate. It is simply just a leaving group and a base. The base will form the alkene.